expand up to x squared. So first of all, in the MF19 we have two formulas, but we cannot use this for paper 3 pure 3. This is for paper 1 pure 1 because the n must be positive integer, but the n we are dealing with here is a negative number. So the first step is to factor out the 2, because in the formula you see we have 1 plus something. So if this number is not 1, we cannot use the formula directly. So we have to factor out the 2. We get this, and notice that if we expand 2 times 1, it's back to this, and 2 times minus 3 over 2, we get back to this. So we are not changing anything actually. So now remember that this 2 is also to the power of minus 2, so that is actually 1/4. And now we can use the binomial expansion formula because we have 1 plus or minus something. So the n in the formula here is minus 2, and the x is minus 3 over 2x, so the minus is included. And then we just follow the formula. We get 1 plus nx and so on. So this is 1 plus nx plus n minus 1 over 2 factorials times x squared. We stop right here because up to x squared. Simplify, use a calculator, we get 3. And here we use a calculator. Remember that the minus 3 over 2 is also squared, so this is actually positive 4 over 9. And after you use a calculator, you get 27 over, this is 9 over 4. And after you use your calculator, you get 27 over 4. Okay, so the last step is to expand 1/4, 3/4, 27 over 16. So that's the final answer. Now the next part is state expansion is valid. So expansion is valid means we use this domain restriction. The modulus of x should be less than 1. So the x in the formula is not this. It's not minus 3x because we didn't use the formula here. This is where we use the formula. So the x is this guy, minus 3/2 x. So that's what we are solving. The modulus of minus 3/2 x is less than 1. You can split the coefficient minus 3/2 and the x, and the modulus of something negative is still positive. So without the modulus, it's just 3 over 2, and then we multiply both sides by 2/3, and we get the final solution. The modulus of x is less than 2/3.